Hi kids, we are starting chapter 8. There are 5 sections. The first is called Ratio and Proportion, which is what these notes are over. Your essential question is, how can I apply the product and ratio theorems to find missing values and calculate the geometric and arithmetic means? Make sure you're writing any points of confusion or questions in your left column. And a lot of this section in particular, actually a lot of this chapter, will be just an extension of some things you learned back in junior high. The first concept, which you already should be aware of, is what a ratio is. A ratio is a quotient of two numbers. So you've got two values and they're being divided by each other. Or one's being divided by the other, excuse me. Some examples of some ways that you can write ratios. For example, let's say my two numbers were 2 and 3. The most common way that we'll use it in this chapter is going to be written as a fraction, 2 over 3. It's pronounced 2 to 3 or 2 over 3, 2/3. You can also write it with a semicolon between the two numbers. This is how we see it sometimes in those ratio questions where we put X with both of the numbers. And the third way, which you won't see very often, it's more of in a sentence form, is by putting the word 2 between the two numbers, 2 to 3. Now there are some some special ratios that you already are familiar with. For example, one is called scale, and we're actually going to do a project with this. Scale is a ratio of the model distance to the actual distance. Scale is used a lot of times on maps. So you can write this definition down if you'd like. Ratio of model distance to actual distance. So an example of this example, on a map you might see, on my map, 1 inch represents 50 miles or something like that. You'll usually see that in the key. That is an example of a ratio, and that's more specifically called a scale. It's used when you recreate or make something bigger or smaller or show like a plan or a map of something that is hard to put on paper because it's so large, so you scale it down. Another type of ratio that is not new to you is slope, and we know that is the ratio of the rise to run. Rise is on top, run is on bottom. So those are just some examples of ratios. Another concept carried over from junior high is that of a proportion. It involves two or more ratios that are equal. That's the relationship. And a proportion is actually a form of an equation. So sometimes we forget that they're actually equations. There is that equal sign there. The most traditional type of proportion is the one you see below. And there are 4 parts. 2 numerators, 2 denominators, they're equal. Now, one thing that you may not have known before is that these parts have special names. So the 2 blue letters, A and D, these are called your extremes. And B and C get the name that they are the means. So you've got means and extremes. Okay. Now, the position of these is very important. So, just off to the side, you might want to write this down. The A over here was in the first position. The B was in the second position. So that's the left side of the proportion. On the right side, the C was in the third position, and the D was in the fourth position. So sometimes we'll refer to these, the second, and we'll call it the second proportional. or the second term, and we need you to know that we're talking about that lower left number or term or expression or whatever is down there. Now there's lots of different ways that we could write a proportion for it to have the same meaning, but what's really important is that the cross products are equal. So let me tell you what I mean about cross products. Back when you were little, or in junior high, not too long ago, you learned how to solve proportions. Some people call it the butterfly method or cross multiply and divide. Those are the shortcuts that they call them. But it's actually a theorem. If you multiply A and D together, that's supposed to be equal to the same thing that you get when you multiply B and C together. AD and BC, these are called cross products. So this is really important to remember. And then this is your traditional proportion. But AD and BC, those are called cross products because you're multiplying them together. So as long as the cross products stay the same, we could write a proportion in a variety of ways. So for example, if I take that proportion up at the top, as long as my cross products are going to be the same, then I'll be good. So for example, I could write that proportion at the top like A over C equals B over D. When I cross multiply or butterfly or whatever it is that you call it, I'm still going to have the same cross products as if I did it to the proportion up at the top. The A and D are still going to be multiplied together. The B and C are still going to be multiplied together. And there's probably 8 different ways you could write this proportion where you'd still have the same cross products. Another way you could write it could be, let's see, what's a good one? You could say D over C equals B over A. When I cross multiply, my cross products are still going to be A times D and B times C. So it's still going to give me the same thing. Okay, so this is just a very simple example, similar to one that you might have seen back in junior high. You have 3 of the terms of the 4 terms needed in a proportion. You need to find out what x is. So the way that we solve this is we cross multiply. We set the cross products equal to each other. It doesn't matter which cross product goes on which side of the equal sign. So if I multiply one way, I get 7x. If I multiply the other way, 3 times 12 is 36. I can write it as 7x equals 36 or 36 equals 7x. These are the cross products. 7x is one cross product, 36 is another cross product. Now we have an equation that just looks more normal to us, and we're able to solve it easily. We're going to divide both sides by 7. So x equals, I can write it as either a fraction, 36/7, or if I want to convert it to a decimal, I think it's about 5.14 something, something, something. So very, very simple if you're just solving a proportion. Okay, so now let's try an example using some of our new vocabulary. It says, find the second proportional, or term, second term, if the first, third, and fourth terms are 2, 4, and 6 respectively. Respectively just means that you keep the order. So the first term is 2, the third term is 4, the fourth term is 6. So the first thing we have to do is set up our proportion, put the numbers in the correct spot. The first term is here, so that's where the 2 goes. We're trying to find the second proportional, or the second term. That goes down here, so we'll just put an x, or some kind of variable. The third term is 4, which goes on the top of the second ratio, and the fourth term is 6. So this is what your equation or your proportion should look like. Now we're just going to solve. We're going to solve just like we did before. We're going to cross multiply, butterfly. Look, you can even make a little butterfly. Woo. On one diagonal or one cross we get x times 4, which is 4x. On the other, we have 2 times 6, which is 12. These two cross products, 4x and 12, we're always going to put an equal sign between them. We just know that that's the relationship. So then we have an equation we can very easily divide by 4, and we get that x has a value of 3, so 3 is our second proportional, or our second term. So now we're going to look at an example from a different perspective. It says find the ratio of x to y when 8x equals 5y. So what they're giving us is they're starting by telling us our cross products. 8 and x need to be on the same diagonal. 5 and y need to be on the same diagonal. Where we put them, that's up to us. Now we need to find the ratio of x to y. So I'm going to first write x to y as a fraction, because that's how we usually see the fractions. The ratios in a proportion. Now this is going to be equal to another ratio, because I want to find this ratio with numbers. A lot of students mess up here. They see, oh, the 8's with the x, the 5's with the y. It must be 8 to 5. And they get it wrong. And I'm telling you, it's about half the kids. This is not the correct way to think about this. What we need to do, rather, is think about how we got those cross products. The y gets multiplied by the top of the other ratio. The x gets multiplied by the bottom of the other ratio. So in my cross product 5y, that means the 5 must go on the top, so it can be multiplied by the y. And the 8 in the 8x needs to go down here so that it gets multiplied by the x. So the ratio of x to y is equal to 5 to 8. This is the ratio they're looking for. They're not asking for the proportion, they're asking the ratio of x to y. It's 5 to 8, not 8 to 5. Make sure that you follow this. Please let me know if you have a question about this, because I don't want you to get it wrong. Put a star or something next to this example so you can come back and look at this. There is a special type of proportion called a mean proportion. Now, we learned earlier that the mean were the second and third terms in a proportion. A mean proportion is a proportion where the means are the same. They're exactly the same. They could be the same number, they could be the same variable, they could be the same expression, but they're exactly the same. So, for example, a mean proportion, if we're talking simply here, might look like 4 over x equals x over 5. The means are the two x's. This guy and this guy, they're the means. The second and third terms. They are the same. Okay, so that has to be present for it to be a mean proportion. The way that you're going to see this referred to in perhaps a sentence, it might be written like this. It'll say x is not just any mean, but it's the geometric mean Sometimes this is called, another name for geometric mean might be the mean proportional. There's all these different names. So those are interchangeable. Between extremes, remember the extremes are the first and fourth terms. Those are the other two. So in this case it would be the 4 and the 5. So x is the geometric mean or the mean proportional between extremes 4 and 5. So if you're given a sentence like this, you're going to set up your equation or your proportion like this, and then you'll solve for x or whatever it wants you to solve for. So just to recap about all of that, the geometric mean is when the means are the same. and the proportion itself is called a mean proportion. Now, you're probably thinking of, oh, I've heard this word mean before. Mean, median, mode, and range, right? In that case, the mean is just the average. You add and divide by how many terms you have. That kind of mean is called an arithmetic mean. This looks like arithmetic, but when it's an adjective, it's pronounced arithmetic. So an arithmetic mean, the way you would find that is you just average. So what you might be asked to average in this lesson would be the extremes. So to find the geometric mean between 4 and 5, like in the last example, we would set up the proportion like we just did. To find the arithmetic mean, we would average the 4 and the 5. So we would add them and divide by 2. So basically, add and divide by 2. So let's try some examples with these. So this example asks us to find both the geometric and the arithmetic means between our two extremes of 4 and 16. So these are the two numbers we're using to find both of those means. So for my geometric mean, that is the way we would find the geometric mean. We would use x as our geometric mean. That's what we're trying to find. That needs to go in the second and the third term. The extremes, the 4 and the 16, are going to go here and here, the first and fourth terms. For the arithmetic mean, this is what you did back in junior high. You're just going to add them. So we'll add 4 plus 16, and then you'll divide by 2. Going back to the geometric mean for a minute, you will use that especially if you get to statistics. It's a statistic term, but right now we're just learning how to find it. So let's solve for both of these. So on the geometric mean, we are going to set our cross products equal to each other. X times x is x squared. And 4 times 16 is 64. These are our two cross products. They are equal. Now to solve this is a quadratic, but because we don't have an x term, an x by itself term, we don't have to set everything equal to 0 and factor. The cool thing is we can just have x squared on one side, our number on the other side, and to get rid of that x squared term, we would just take the square root of it, which means we would have to do that to both sides. The square root of x squared is actually just x. The square root symbol, or the square root operation and the squaring operation are opposites, so they undo each other. And that's going to equal the square root of 64, which has two square roots. It can be a positive or a negative 8. Positive 8 times positive 8 gives you 64, and negative 8 times negative 8 gives you 64. So you actually have two values that could be the geometric mean for 4 and 16. For the arithmetic mean, we're just adding 4 and 16, so that's 20, dividing by 2 is 10. It's a little bit of an easier process. All right, last example. This question is asking, is this proportion equivalent to this proportion? Basically, do they mean the same thing? Do the x and c in each proportion have the same relationship? Now, at first glance, they look slightly different, but they do have some things that look the same. If we can somehow get these equations or these proportions to look exactly the same, then we will know that they are equivalent and mean the same thing. So the first thing I'm thinking is, let's get these in a different form. We know that with a proportion, we can rewrite it without losing the relationships by setting the cross products equal to each other. So that's the first thing I'm going to try. I got this times this, and I got this times this. We'll do this one first. 4 times c is 4c. X minus 5 times 3, I would need to put the 3 outside the parentheses. Make sure to leave that x minus 5 in the parentheses because you're multiplying by that whole term. And these two cross products are equal. Okay, so there's my cross products. Let's go to the other proportion. In this one, I have two sets of parentheses that are going to be part of both cross products, so make sure to leave those parentheses there so that you know to distribute that other number. This time, I've got 4 times c plus 3, and my other cross product is 3 times x minus 1. And these cross products are equal. So now that I've set the cross products equal to each other, I've got them out of fraction form. So I'm looking at them, they still don't look exactly the same. Maybe if we got rid of the parentheses and maybe combine some like terms, we could start to get them to kind of look similar. So that's going to be the next thing I do. Let's go ahead and get rid of these parentheses. So on the left equation, I'm going to distribute that 3 to the x and to the negative 5. 3 times x is 3x. 3 times negative 5 is negative 15. Okay. On the right side, I'm going to distribute the 4 and the 3. 4 times c is 4c. 4 times 3 is 12. 3 times x is 3x. 3 times negative 1 is negative 3. Okay, so let's look at this. They're starting to look a little bit better. I can see that the equation on the left only has 4c on its left side, whereas the equation on the right has 4c plus 12. Maybe if I move that 12 to the other side, they'll look even more the same. So I'm going to subtract 12 from both sides, and I've got 4c equals 3x. I can only subtract the 12 from the negative 3 because those are the only like terms there, but I'm going to get negative 15. And oh my gosh, look at this. 4c equals 3x minus 15, 4c equals 3x minus 15. Now I don't know the value of c and x, but I can see from both of these equations, since they look exactly the same, that means they are equivalent, and yes, these are equivalent. They have the same meaning, they preserve the same relationship between c and x. Alright, so the problems for 8.1, if you choose to work ahead, are 3, 4, 6, 7, 9, 11, 12, 15, 17, 19, 20, and 24. And it seems like a whole lot, but I don't think it's going to take you near as long as you think it's going to take. Have a great rest of your evening, and I will see you later.